Hello and welcome to another geometry lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 3, Lesson 3 on drawing inferences from geometric givens. That sounds heavy, and it's not really. All we're going to be doing today is really practicing what we can get out of a piece of information that we're told. And most of this stuff we've actually been kind of working with up to this point in time. But we're leading up to what, for many students, is the hardest part of geometry, which is known as geometry proof. And today, we're going to start to kind of delve into that a little bit. So, let's do it. Inferences. We now move into a part of geometry where we will prove properties about geometric figures by using information we are told and reasoning based on previous geometric results. We start by understanding what inferences we can make from what we are given to begin. So let's first talk about just what an inference is. I think you've probably heard the word, but let's make sure you understand it. An inference is a conclusion that is based on evidence, reasoning, or prior conclusions. All right, now mostly for today, right, inferences are just going to be like, here, I told you that this is a bisector. What can you infer from that, right? And you're going to say, oh, well, a bisector cut this particular thing in half, so this thing is congruent to that thing, right? That's all we're getting at today. And it should be fairly simple. Let's take a look at exercise number 1. In the diagram below, it is given that ABC, segment ABC, and B is the midpoint of AC. All right, so letter A asks, what does the given of segment ABC allow you to conclude? All right, now this is important because many times in proofs, we will be told something that looks like this, all right? What does that allow us to conclude? Pause the video now and see what you can write down. All right, well, what it tells us, right, is that A, B, and C are collinear. Now, we can actually infer two things from that. One thing that we can infer from that is that AB plus BC is equal to AC. All right? And that is probably the most common thing that we will infer from something that looks like this. There is one other thing that we can infer, which is that angle ABC, or the measure of angle ABC, is equal to 180 degrees. Either one of those are pieces of information that we can infer from knowing that points A, B, and C are collinear. Now let's go on to the other given, letter B. What does the given of B is the midpoint of AC allow you to conclude? Well, why don't you write something down? All right, well, you could write two things down. In this case, those two things really are more or less equivalent, which is one of them being that the length of AB is equal to the length of CB, whoops, not CD, CB, or you could say that segment AB is congruent to segment CB. And of course, the order of those letters in the segments doesn't matter, all right, or in this statement. Now, again, these two really are, for all intents and purposes, equivalent statements, right? Because the definition of two segments being congruent is that their lengths are equal. And if their lengths are equal, then the segments are congruent. So these two are really stating the same thing. These two are actually stating something different, right? This is the length of segment AB plus the length of segment BC is equal to the length of segment AC. This is that the measure of angle ABC is 180 degrees, or angle ABC is a straight angle, either one that you want to look at. All right, let's keep going. Right? Now, it is very important to be able to take information that you were told, those are what are going to be called your givens, and come up with conclusions about angles and segments. So let's take a look at exercise number 2, where we work with a variety of givens and terminology that we've seen in the past. For quadrilateral ABCD shown, diagonals AC and BD intersect at point E. For each given below, state conclusions you can make based on the givens. Give a reason, a definition, that justifies your answers. All right, let's do the first one together. Letter A, given segment BD bisects angle ADC. So, right, we are being told, we are being given that segment BD bisects angle ADC, right? So what we can say about that is we can say those two angles are congruent. So we can say that angle ADB or ADE, it doesn't matter which one you use, angle ADB is congruent to angle CDB because, this is this part, give a reason, because an angle bisector divides an angle into two congruent angles. And by the way, it is okay when you're writing stuff out to do some abbreviations and even to replace things like the word angle with an angle symbol and the word congruent with a congruent symbol. I even can pluralize the angle symbol. So that's angles, because an angle bisector divides an angle into two congruent angles. All right, letter B. Given segment AC and segment BD bisect each other. All right. So again, forget about this one. Let's now work down here. See if you can write down what conclusion or conclusions you can make based on this particular given. All right, well, bisecting in general means to cut in half or to cut into two equal portions. Now, given that diagonal AC and BD bisect each other, it means that they both cut each other into equal parts, meaning that AE must be congruent to CE and DE must be congruent to BE. So let's write those down first. AE is congruent to CE and BE is congruent to DE. And I'm going to just carve out some space here because segment bisectors divide or cut or whatever a segment into two congruent segments, right? Simple enough, because segment bisectors divide a segment into two congruent segments. Finally, letter C, given AC is perpendicular to BD. All right, well, what can you state in this case? Write something down and then write a reason or definition why that happens. All right, well, we're going to be given things about perpendicularity all the time. Let's mark it on our diagram. AC is perpendicular to BD. That means, right, that all four of these angles are right angles. So I could say angle AEB, angle BEC, angle CED, and angle DEA are right angles because perpendicular lines form right angles. Right? AEB, BEC, CED, and DEA are all right angles because perpendicular lines form right angles. Simple enough. Pretty much the definition of perpendicular lines. All right, exercise number 3. In the diagram above, if we are, well, now it's not above, it's below, but you know what I mean. On your sheet of paper, it's above. In the diagram above, if we are given that AC and BD bisect each other and AC is perpendicular to BD, what one term summarizes the relationship between AC and BD? What do you think? Pause the video now, and what can you write down? Well, they are each other's perpendicular bisectors. They are each other's perpendicular bisectors. By the way, we're going to eventually see that the particular shape that we're working with here is what's known as a rhombus. And in a rhombus, the two diagonals, in fact, are both perpendicular to each other and bisect each other. Therefore, they are each other's perpendicular bisectors. All right. Now, there's some additional terminology that you've likely seen in other courses, but that is going to pop up in this course as well, and that we have to know so that if we are given these particular pieces of information, we can make the right inferences or conclusions based on it. So let's talk about medians and altitudes. A median is a line segment drawn from a vertex of a triangle to the midpoint of the other side. So let's take a look before we go on and talk about altitudes. In this first particular diagram, right, I've marked point D, which is the midpoint of line segment AB, and I've drawn a segment from C to that midpoint D. So segment CD would be the median drawn to segment AB. Now let's talk about an altitude. An altitude is a line segment drawn from a vertex of a triangle, perpendicular to the opposite side, and ending on the line containing the opposite side. It might not actually be the opposite side itself, depending on whether like the side you're drawing it to kind of has an obtuse angle or an acute angle. So again, here, I've got a line segment drawn from point A down to side BC, and it's perpendicular to side BC. So I would say that segment AD is the altitude drawn to segment BC, or to side BC. Okay, simple enough. Now we have to be able to use that terminology. So it's simple enough, right? Let's take a look at exercise number 4. In triangle MNP shown below, points Q and R lie on MP. State a conclusion you can make based on each of the following givens. Give a reason, definition, for your answer. Letter A. Given NR is an altitude of triangle MNP. All right, so NR is an altitude of triangle MNP. What can we know about that? Well, we can tell that this and this are right angles, right? So I can say that angle NRP and angle NRQ or NRM, I'll use NRM, are right angles because altitudes are perpendicular to the base, well, to the side they are drawn to. All right. That should be the word drawn. Now that I look at it, that W just seems questionable. Let me just write that in a little bit better. The altitude they are drawn to. A little better. Okay, let's take a look at letter B. Given NQ is a median drawn from point N to side MP. All right. Now, medians are probably a little bit newer to you than altitudes. You've certainly seen altitudes before in geometry work that you've done in middle school, right? Median could be a little bit like sort of new, but think about medians in statistics, right? The median in statistic is the number that's right in the middle. A median is very similar in that it is a line segment drawn from a vertex to the middle of the opposite side, right? So we could conclude a variety of things from this. We could conclude that Q is the midpoint of MP, or we could conclude, probably more likely, that MQ is congruent to PQ, and that's because, right, because medians bisect the side they are drawn to. All right. And again, what's going to happen in every lesson, starting in the next lesson and going forward in this unit, is we're going to have a lot of problems that start off with given this and this, prove the following. All right? And we have to be able to take those givens and can correctly infer what they tell us. Really important. All right, let's look at one last one. Sometimes you will need to make conclusions based on the diagram alone, although you will still need to rely on information that you're given. This kind of goes back almost to the first problem that we saw, but let's talk about exercise number 5. In the diagram below, we are given that segment EFG and ray FH is drawn. Letter A, what kind of angle pair must angle EFH and GFH be? Pause the video now and see if you can write what kind of angle pair those two angles have to be. Well, I'm really happy with one of two answers. You either said that they were a linear angle pair or a supplementary angle pair, right? So either a linear angle pair or a supplementary angle pair. And again, we know that for really one reason and one reason only, which is that points E, F, and G are collinear, and that's what tells us that, right? Those will be very subtle ones when we're given them in proof, but we'll need them in order to make certain conclusions. And specifically in letter B, what can we conclude about them based on letter A? Well, pause the video now and see if you can write something down that you can conclude based on the fact that you know that they're a linear angle pair or a supplementary angle pair. You're going to be able to conclude the same thing either way. Well, what you can conclude is that their measures sum to 180 degrees. In other words, the measure of angle EFH plus the measure of angle GFH equals 180 degrees. This one didn't ask us for a reason, but of course the reason would be because linear angle pairs add up to 180 degrees or because supplementary angle pairs add up to 180 degrees. All right, one more problem. Exercise number 6. In the diagram shown, line RS and line TU intersect at point V. What type of angle pair, in letter A, is angle RVU and angle SVT? Go ahead and write something down. All right, well, let's locate those two angles on our diagram. RVU is this angle, SVT is this angle, and that is one of those great vertical angle pair. It's a vertical angle pair, right? Now, letter B, what can you conclude based on A? Mark on the diagram. Kind of already have marked it on the diagram, but you can conclude that the two angles are congruent. Angle RVU is congruent to angle SVT. And again, the reason for that would simply be what we already know, because we've kind of proved it twice over now, which is that vertical angle pairs are congruent. Simple as that. All right, let's summarize. Today's lesson was a real what I call setup lesson. In other words, we're going to be using what we've kind of been doing today throughout the rest of this unit. We're going to be given information about a particular geometric diagram, and then we're going to have to draw inferences from that information and eventually make conclusions then even from the information that we've inferred. And we'll start all of that in the next lesson. For now, I just want to thank you for joining me for another geometry lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.